So, hello everyone, welcome to this tutorial video. In this tutorial video, we will discuss a problem on bit manipulation or bit. So, after reading this whole question, we can conclude that we want to build an algorithm which made n-bit gray codes, okay, which help to reduce the which help to reduce the transmission error and transmission error while communicating. Okay, so how can we generate n-bit gray code? We will see. So the input, what are the input formats? So the first line contains the integer t, which is the number of test cases, and we have one integer n, which represents the number of bit in the gray code. Okay, constants are very simple. T is lie between 1 to 100 and lies between 1 to 16. Now we will move on to the sample input. So sample input. First, we understand what is our actual problem. Okay. So let me understand what is gray code first. So basically, the gray code is a binary numeral system where each successive number differs from the previous one by only a single bit. Okay, this property makes it useful in digital system where minimizing error is important, such as in communication system, transmission signals, rotary encoders, and error correction. Okay, now we will move on to the first. We will move on to the example. Now, for n equals to 2, we want to generate a gray code for n equals to 2. It means 2-bit gray code. Um, so 2-bit gray code looks like. So in 2-bit gray code, we have only 2 bits like this 00, 01, 11, and 10. There are only 2 bits are used. Okay. Now let see this one for n equals to 3-bit. The For n equals to 3, the 3-bit gray code sequence is 000 001. It means we using 3 bits to generate gray code. Okay. So how it is generating? Mm, we start with 00. In gray code, at a time we just change only 1 bit. We can change only 1 bit. So here 00, now 002 01. Okay, 00 002 01. We are changing only 1 bit. We are changing only zero, this 0 to 1. Now after this we are changing this 0 to 1. Okay. Now after this we are changing this 1 to 0. So we get 4 bits. Okay. Now look here, look in this example for n equals to 3. So we start with 000, and in first step we change first bit, this bit, 02 we change 0 to 1, then this bit 0 to 1, then again this bit 1 to 0, like this and so on. Okay. Now here if you analyze it properly, what we are actually doing is just shifting 0 to 1 and 1 to 0 only at a time, only shifting 1 bit. Now here for n equals to 2, how many numbers are there? 1, 1, 2, 3, and 4. We have 2 to the power 2 numbers. Okay. For n equals to 3, we have 1, 2, 3, 4, 5, 6, 7, and 8 numbers. Like for 2 to the power 3. For n equals to 2, we have 2 to the power 2, or for n equals to 3, we have 2 to the power 3 numbers. So this is equals to 8, and this is equals to 4. And one more thing, if you notice here, is for first two numbers, the prefix is 0. Like here, first digit is 0, and here also first digit is 0. And other two number, the first digit is 1. Same for this example also. Here are 8 numbers, so we divided it by 2. For first four numbers, the prefix is zero, like this: zero, 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 zero. And for other four numbers, the prefix is one, 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 and one. Okay, understood. So, what is the gray code and how we are doing it? Now we will see. We will see program. Here is the code snippet. Okay, so we define the function gray code and one list result which stores the base case. It means basic gray codes 0 and 1. Then I use for loop for I in range 1 to n. I want to iterate for n times. Therefore, I use this. And here I used to wait. I made one more list mirrored, which is basically the reverse of first list result. Here mirrored stored 1 and 0 and result stored 0 and 1. Basically, mirrored is a mirror image of result. Okay. Now, if we look this example like 000111 and 10. For first two number, the prefix is 0 and 0. And for another other two numbers, the prefix is 1 and 1. Here we are doing same thing. Like we are uh, using 0 as a prefix, and then we use this list comprehension code for code in result. It means it makes a pointer to the result list. This pointer is pointing to the very first element of result. So now 0 plus this 0 also string. So here we use concatenation of string 0 and 0. This will print this, and now this pointer shift to this 1 and it will print 0 and 1. So our first list is completed, plus simultaneously this second statement also runs. And in this statement, we use 1 as a prefix. Okay, 1 as a prefix. So we fix this 1 here and here. Now, this code pointer pointing to the mirrored. Here is mirrored. Mirrored is the list. This code pointer is pointing to the mirrored. So the first element of mirrored. So this is the count code pointer. Okay, pointing to the 1. So it will write 1 here, comma. Now this pointer shift to the 0. And how it is shifting? Because we are using for code in mirror. It means this will iterate all the element of mirror. Same for this, code will iterate all the element of result. So here 1, now it shift to 0. So this will write 0. So in final answer, which we stored in result is adding both lists. It means 000111 and 10, and we are returning it. But we use this join statement to remove commas between two digits like this. We are removing this commas. Okay, so now we will see this in um, compiler. Okay, we run this code. We are taking t as in t input and using for loop for n time for t times. And we are taking n as an input and printing the gray code. Okay, so I'll run this code. Okay, now go to the submit code button. Just submit my code. Okay, we pass all the test cases. So thank you for watching this video.